Okay, we're still in 1.1 with the next section here being discrete and continuous functions. Basically, we want to see that maybe in real world situations, you can only use discrete functions, only certain numbers actually work. So you'll see that the graph is not all connected, only certain values work. Like if I was selling tickets, I can't sell 1.5 tickets, right? It'd be like 1, 2, 3, etc. Versus continuous functions where like all numbers are reasonable. And basically on a continuous function, the graph will be a line or an unbroken curve. It's all connected. Okay. A discrete function is discontinuous. It's a function in which the points are not connected. Discontinuous is basically a function that is not continuous. There's some sort of break or jump in the graph that we'll see here in a second. Let's see how these might look. So if we look at this function, we want to see like, is it discrete, continuous, or neither, and state the domain and range. So if you look at this graph, I mean, it just keeps going down, it curves, and it keeps going up. There's no like individual points that it necessarily hits. It hits everything in between. It's all connected, so it is continuous. Okay, no curve, a curve with no break or discontinuities. Okay, and really the graph keeps going up and down and it keeps getting further to the left and the right. So the domain and range are actually both going to be all real numbers. Pretty straightforward and pretty easy. That's kind of like most of the things we're going to see. But every now and then we come across some odd things. Like this one here seems to be just a normal line, except right here at this point at 2, 1, there's an issue. There's a hole in the graph right there. There's a value that doesn't work. So this function is a neither, or you could say it's discontinuous. There are continuous sections, but there's a break at 2, 1. It's not defined when x is 2. When x is 2, you would think it hits 1, but for whatever reason, that does not work in this situation. We'll explore some of that this year, but this doesn't work. So the x values of the domain will be everything except when x is 2, and the range will be everything except for when y is 1. Everything else is fine. Our last example here shows an example of a discrete function. It's made of distinct points that are not connected. So we've got individual points and things like that. We may not be able to connect them because maybe it's values that don't make sense. We have to use whole number answers for these. Okay. Your domain, you can't use an interval for this. You have to say it's basically these exact numbers. We use when x is -3, there's a value. When x is -2, there's a value, there's a point. -1, and then so on. 1, 3, and 4. The range is only certain values also. This is a y value of -3, a y value of -2, a y value of 1, a y value of 2, 3, 4, so on. So you have to list out the individual values that are used. Can't say it's everything in between. Can't say it's everything between -3 and 4 because I literally don't use all those numbers. What about 0? What about 2? What about 1.5? So can't list them all out like that. Let's look at this real world situation and determine some continuities. So determine whether this here represents a discrete, continuous, or a neither function, say the domain and range, all that good stuff. So obviously I'm going to buy some coffee based on some different weights. I have different prices. Okay, so up to 2 pounds. Well, the up to 2 pounds thing would actually be continuous. Okay, it's continuous over that. From 0 to 2, you basically have a continuous cost that just keeps going up, be some sort of line that just keeps going up. Cool. For the larger values, though, anything like basically over 2, they have to like break it up. You could buy straight up 2.5 pounds, 3 pounds, 5 pounds, but you can't really get anything in between. So these are discrete individual points. So for the rest of it, it's discrete. Okay. Since it's made up of neither a single interval nor individual point, it's a neither situation. It's not continuous all the way. It's not discrete all the way. So it's neither one really. It's a bit of both. So it doesn't work at all. The domain of this function is from 0 to 2, or where x could be 2.5 or 3 or 5. It could be those individual values. Those are the only numbers we're allowed to use. Clearly, you can't buy anything over 5 pounds. You can't buy 4 pounds. You'd have to like pick something else. I even kind of wonder if some of these values even really work. 5 pounds might seem like it's way too expensive. Kind of jumps. But we'll see. This also represents the possible weights of coffee beans. So our x values, our domain represents different weights. Now the range here could be from 0 to, my first thought is, from 0 to 8, but no, if you really think about it, it's $8 per pound. So if I buy 2 pounds at $8, it really goes from anything from 0 up to $16, or you could spend $20, $22, or $35 to get these individual Y values. And this represents your different costs. All right, so there we go.